Welcome to Alphanumeric Tricks. In this video, we are going to see the topic problems under elimination of arbitrary constants and form a partial differential equation. This is the continuation of the problem set of the topic elimination of arbitrary constants, and the previous problem set link is given in the description box. Now we will see some more problems in this topic. Consider the problem. You have to form a partial differential equation by eliminating the arbitrary constants a and b from log of az minus 1 is equal to x plus ay plus b. Now you have to consider the given problem as equation 1, that is log of az minus 1 is equal to x plus ay plus b is taken as equation number 1. Now you can predict the order of the resulting PDE using the arbitrary constants and the independent variables. In our problem, the number of arbitrary constants are 2, which is a and b, and the number of independent variables are 2, which is x and y. Both are equal, so the resulting PDE we obtained is of order 1. Now you have to differentiate 1 partially with respect to the independent variable x. So what is differentiation of log x? Yes, it is 1 by x. In the same way, differentiation of log of az minus 1 is also equal to 1 by az minus 1 into, you have to differentiate the denominator with respect to x because z is a function of the variable x and written in the numerator. Now we will do the derivative for the denominator. A is written as it is differentiation of z with respect to x is dou z by dou x minus differentiation of 1 becomes 0. So after taking derivative of the denominator, the final terms you have as a into dou z by dou x is equal to, you have to do the differentiation for the right hand side terms. Differentiation of x with respect to x becomes 1 plus ay is taken as constant because the partial derivative with respect to x we are doing, so y is taken as constant, so differentiation of this constant becomes 0. In the same way, b is constant, so the differentiation of constant becomes 0. So after taking derivatives of RHS, the resulting term you have as only 1 alone. Now you have to use the notation dou z by dou x as p. So you have 1 by az minus 1 into ap is equal to 1. Number that equation as 2. What is next step? Yes, you have to differentiate 1 again partially with respect to another independent variable y. So differentiation of log of az minus 1 is 1 by az minus 1 into the differentiation of az minus 1 with respect to y. We have to do it, and that is written in the numerator. So a into differentiation of az with respect to y is dou z by dou y, which is taken as q minus constant differentiation becomes 0. So the resulting term you have as a into q, which is equal to, you have to do the differentiation, that is partial differentiation for the right hand side terms. The differentiation of x with respect to y becomes 0 because x is constant, plus a into differentiation of y with respect to y is 1 plus differentiation of b with respect to y is constant, that is 0. So in our left hand side and the right hand side terms you are having a, so both we can cancel this a. Then the resulting term you have is 1 by az minus 1 into q is equal to 1. Number that equation as 3. Now how will you eliminate the arbitrary constants a and b here? Yes, in previous problems we done this way using equations 2 and 3. In 1, that is substituting the constant values which is readily available in equations 2 and 3 substituted in equation 1, and you can form a partial differential equation. But in this problem that is not possible because equations 2 and 3 does not have the constant term b value. So the substitution in 1 is not possible. We have to do some other way to eliminate the arbitrary constants. Then how will you eliminate? Here let see the equation 2 and 3. Here in this equation 2 and 3, 1 by a z minus 1 is a common term. So divide 2 by 3, then the term is eliminated. So equation 2 by 3 gives 1 by a z minus 1 into ap divided by 1 by a z minus 1 into q is equal to 1 by 1. Here 1 by a z minus 1 and 1 by a z minus 1 get cancelled. What is remaining terms here? AP divided by Q, which is equal to 1, or you can take this Q to right hand side and can be written as AP is equal to Q. From this equation you can easily find out the value of A. So A is equal to Q divided by P, that is P is taken to the denominator of the right hand side. So you have A is equal to Q by P, number that equation as 4. Now the value of A is obtained here. So substituting A in either equation 2 and 3, you can eliminate the arbitrary constants and to form a partial differential equation. Suppose you are substituting the value of A in first equation, we can't eliminate the arbitrary constants and PDE is not obtained because the B value is not obtained from any of these equations. So we have to substitute equation 4 in equation 3 now. So you have 1 divided by A is replaced by Q by P into Z minus 1 into Q is equal to 1. Here the denominator you have to take the LCM QZ minus P divided by P, that P is taken to the numerator. So you have P divided by QZ minus P into Q is equal to 1. Now we have to simplify further. For that you have to take QZ minus P to the right hand side. So it becomes PQ is equal to QZ minus P. Again simplifying, that is you have to take this minus P to the left hand side. So you have it becomes plus C, PQ plus P is equal to QZ. Here which is common in this term? Here P is common, so take it outside. P into Q plus 1 is equal to QZ, which is the required partial differential equation. Now we will see the next problem. You have to form a partial differential equation by eliminating the arbitrary constants A, B and C from x squared by A squared plus y squared by B squared plus z squared by C squared is equal to 1. Here you have to remove 3 constants in this problem. As usual, you have to take the given problem as equation 1, that is x squared by A squared plus y squared by B squared plus z squared by C squared is equal to 1 is taken as equation number 1. Here also you can predict the order of resulting PDE. How many arbitrary constants available here? 3 arbitrary constants A, B and C. And how many independent variables are there? 2 independent variables x and y. So 3 is greater than 2. Therefore the resulting PDE we obtained is of order 2 or higher order. So we have to find out the second derivatives also in this type of problems. In previous problems and all, we just find out the first derivative P and Q alone. Whereas in this type of problems, in this type of case, you have to find out the second derivatives also. Now you have to differentiate one partially with respect to the independent variable x. Then you have 1 by a squared is constant. What is differentiation of x squared? It becomes 2x plus y squared by b squared is constant. Because why it is constant? Because we are doing partial derivative with respect to x. So another remaining variables are taken as constant. And what is constant differentiation? It becomes 0. So this is not present. Plus again here 1 by c squared is constant. And differentiation of z squared is 2z into z is differentiated partially with respect to x. So you have 2z by 2x is equal to 0. So from this equation you have 2 is common. So take it outside. 2 into x by a square plus 1 by c square into z into 2z by 2x is taken as p is equal to 0. From that you have to take 2 to the right hand side because 2 is in product. when you're taking 2 to the right hand side, it comes to the denominator. So 0 by 2 is 0. That is 0 by anything is 0. So you have the term after simplification is x by a squared plus zp by c squared is equal to 0. Number that equation as 2. Now since we have to find out the second derivative, so you have to differentiate 1 again partially with respect to the if you have to differentiate 2 again partially with respect to the independent variable x. When you are differentiating this equation 2 with respect to x, you can get the second derivatives. So first you have to write 1 by a squared is constant, and differentiation of x with respect to x becomes 1 plus 1 by c squared into, here z is a function of x and p is a function of x, so product of two terms is there, so you have to go for uv rule to differentiate this term z p. What is uv rule? Yes, first you have to keep first term constant, you have to do the differentiation for the second term, plus you have to keep the second term constant, do the differentiation for the first term, that is u into v dashed plus v into u dashed. Now apply here. So first term here is z into differentiation of p with respect to x, we have to do it. What is p? P is dou z by dou x, that is differentiated again with respect to x partially. So dou by dou x of dou z by dou x, you have dou squared z by dou x squared, plus you have to keep the second term constant, that is dou z by dou x into differentiation of z with respect to x, we have to do it, that is again dou z by dou x. So dou z by dou x into dou z by dou x, you have dou z by dou x the whole square, which is equal to 0. From this, you have to use the notation dou squared z by dou x squared is taken as r. This is standard notation we are using in partial differential equation, and dou z by dou x is taken as p. So you have 1 by a squared plus 1 by c squared into zr plus p squared is equal to 0. From this equation, that is you consider this equation and the second equation, here 1 by a squared and 1 by c squared is present here. So using these two equations, we try to eliminate the arbitrary constants. For that, you have to simplify this equation. So keep 1 by c squared zr plus p squared one side, and plus 1 by a squared to another side, it becomes minus 1 by a squared. Here you have to rewrite this equation, that is keeping constant terms one side and variables another side, that is zr plus p squared into minus c squared by a squared, because c squared is taken to the numerator of right hand side. So you have zr plus p squared is equal to minus c squared by a squared. Number that equation as 3. Now in the same way, in equation 2 also rewrite it and find out the values of c squared by a squared. Now you have to write this equation, zp by c squared is equal to x by a squared is taken to other side, it becomes minus x by a squared. Here also you have to arrange, that is you have to combine the constant terms together and variables together, that is you have to take c squared in the numerator of right hand side and x in the denominator of left hand side. So you have zp by x is equal to minus c squared by a squared. Number this equation as 4. Here in equations 3 and 4, the right hand side terms are equal, that is equal to minus c squared by a squared. So you have to equate these two terms or substitute one equation in the another one. You can eliminate the constant a squared and c squared. So you have substituting 3 and 4, you have zr plus p squared is equal to this is replaced by, that is instead of minus c squared by a squared, you replace zp by x. Now you have to take this x to the numerator of left hand side. So you have x into zr plus p squared is equal to zp, you have to take x inside this terms, x zr plus xp squared is equal to zp, you have to take this zp to the left hand side, it becomes minus zp, that is xp squared plus xzr minus zp is equal to 0. This is the required partial differential equation. Here it is of order 2 because the equation is having the second order derivative dou squared z by dou x squared, that is r is present in this equation. This is one method to form a partial differential equation for this problem. We have another method also to form a partial differential equation by eliminating A, B and C. How it is possible is you have to find out the derivatives P, Q, R, S and T. Using those derivatives, you have to eliminate the arbitrary constants and you can form a partial differential equation. That equation and this equation is not same, because the solution is not unique in this type of problems. That is, the equation is the PDE is not unique in this type of problems. That thing you should remember. And that is for today's session. If you have any doubts in this, please comment in the comment section. And we will see some more problems in the next topic. Thanks for your time and thanks for watching.